All right, now we're going to look at practice G. Which is elastic collisions, and we'll do number 1 together. So we're going to write our given. It says a 0.015 kilogram marble, so I'm going to call that MA, is sliding to the right, so I need to, again, establish my sign convention. I'm going to use my standard Cartesian sign convention that up and to the right is positive. So because it's saying it's going to the right, I'm going to say that that's positive 22.5 centimeters per second. On a frictionless surface, make an elastic head-on collision with another marble. It's the same mass. So MB is equal to 0.015 kilograms, moving to the left. So if it's moving to the left, that's going to be negative 18 centimeters per second. And if I looked at this conceptually, if one marble's going this way and the other one, if they collide head-on, this is obviously to the left. Now, sometimes you'll read problems and they won't say, oh, this is to the left. But because it's a head-on collision, if this is going this way, this one has to be going the opposite way if it's head-on. Okay. After the collision, the first marble moves to the left. So after the collision, VA prime is equal to negative 18 centimeters per second. So now it says, now these have the same mass, and because this is 18, I can pretty much already figure out what the answer is without doing it mathematically. But we're not going to always have problems where the values are the same. But let's go ahead and do this. So we're just going to, we're going to find VB prime, and then we're supposed to find also, verify your answer by calculating the kinetic energy before and after. Oh, that's supposed to be A. So MAVA plus MBVB. This is the total momentum before, which is a sum of the momentum of A plus the momentum of B, is equal to. Now remember, the equal sign is like the event. So in this case, the equal sign is the collision. So the total momentum before is equal to the total momentum after. Now the two marbles, they collide, they don't stick together. They each move off with their own velocity. So that's going to be MAVA prime plus MBVB prime. What do I want to solve for? I want to solve for VB prime. So I'm going to rearrange the equation to solve for the unknown in terms of the known. MAVA plus MBVB minus MAVA prime divided by MB. Now, unfortunately, nothing is 0, so now I have to substitute all my values. I'm just going to write the numbers right now. I'm not going to put the units. So 0.05 times 22.5. So your question is, why am I not converting this to meters per second? Well, when I do all this, my final answer will still be in centimeters per second. Okay? Plus 0.015 times negative 18 minus 0.15 times negative 18. So this is where you have to be careful. A negative times a negative is a positive. And this is where people make their greatest mistakes. You know, you try to do it fast, you try to just plug numbers in your calculator, you don't rearrange the equation to solve for the unknown terms of the known, and then that's where you're going to mess up. So there's reasons why we do it this way, so we don't make mistakes. And when we do all that, VB prime comes out to be 22.5 centimeters per second. Because this is positive, that means it's to the right. If it came out to be negative, that would be to the left. Now, when you think about it, conceptually, this makes sense. The marbles have equal mass, and so if this one's going to the left with that velocity, then this would have to be the same as that. Then part B, it said to verify this using this. So let's see. The kinetic energy before, KEI, is going to be 1/2 MAVA squared plus 1/2 MBVB squared. So when I substitute in my values, I have (0.015) times -18 squared. The kinetic energy before comes out to be 6.2 times 10 to the -4 joules. Now I'm going to look at the kinetic energy after. So I'm going to say this is a elastic collision. So whatever one marble loses, the other one's going to gain, but the total kinetic energy is going to be the same. So let's see if that works out. So the total kinetic energy after KEF is going to be 1/2 MA times VA prime squared plus 1/2 MB times VB prime squared. So when we're doing these problems, it's not like they're difficult. They're just kind of tedious because there's a lot of variables. So this is 1/2 of 0.015 minus 18 squared plus 1/2 0.015 0.225 squared. So when we do all this stuff, the final kinetic energy comes out to be the same. And this is what they meant by verifying your answer by calculating the total kinetic energy before and after. And that's what we did.